Hello, welcome to the second video of a math primer for Honors and Regents Physics. I'm going to skip ahead to part 2 now. So part 2, we're going to look at a few different things. Dimensional analysis, which you might know as factor label method, is just a fancy way of changing from one unit to another set of units by multiplying by fractions that are equal to 1. Significant figures, which are just an indicator of how confident you are in the accuracy of a measurement, and metric prefixes, which are like, centi, kilo, milli, for example. It's also worth mentioning, because I didn't put it in here, that you really should check out your scientific notation. If you are rusty on your scientific notation, you want to make sure that you go over that and that you're familiar with scientific notation. Let's skip ahead to dimensional analysis. Dimensional analysis is just a way of taking a measurement and essentially, without changing the value of the measurement, usually changing the units by multiplying by a fraction that is equal to 1. And you can use this to change from one set of units to another. So let's take, for example, I'll change my pen color. 1 meter is equal to 100 centimeters. Now, if you have a 1 meter equal to 100 centimeters, and we divide both sides by 1 meter, for example, 1 meter divided by 1 meter is equal to 1. So 1 is equal to 100 centimeters over 1 meter. And you can do this the other way around too, and you can say 1 is equal to 1 meter over 100 centimeters. Now, you're not always going to want to use them in the same situation, but they are both fractions that are equal to 1 because the top is equal to the bottom. Even though the units are different and the numbers are different, we know that the size of the measurement, 1 meter, is the same as the size of a 100 centimeter measurement. Okay, so now let's say that you actually take a measurement and you get your value to be 5 meters. You could multiply 5 meters by 1, and that's not going to change the value of your measurement. You still have a measurement of 5 meters. So rather than multiplying by 1, we're going to multiply by a fraction, or where the top is equal to the bottom, and so that they are equal to 1. So 5 meters, 5 meters is equal to 5 meters times a fraction where it's equal to 1. And I'm going to put in 100 centimeters over 1 meter. And we know that 5 meters equals this value because that's really just a fancy way of saying the number 1. Now, as we do this multiplication, notice what happens to the units. The meters divided by the meters end up going away. So that is equal to 500. And then the only units that are left are centimeters. So we know that 5 meters is equal to 500 centimeters. So that's dimensional analysis in a nutshell. Now you might ask, how do you know what to use? How do you know which fraction to use? So let me actually erase this, and let's try this again here. And this time, let's say 5 meters. So 5 meters is equal to 5 meters times 1. But what if this time we put 1 meter over 100 centimeters? Notice what happens to the units. The meters don't cancel out. Instead, what you end up getting is 5 times 1 is 5 meters squared over 100 centimeters. So that's technically correct, but it doesn't make a whole lot of logical sense. 5 meters squared over 100 centimeters is equal to 5 meters. But ideally, what you really want to do when you're trying to solve these factor label method questions is you want to put in a fraction where you know that the numerator and the denominator are going to cancel out when it comes to units. Does it not work with my finger? It only seems to work with it. Okay. So you really can start with this, and you can say, well, I know meters needs to go away. So then what do I put in the top and what do I put in the bottom? And we probably want to put 1 meter here, although we don't have to. and you could put 1 meter is equal to 100 centimeters. That's fine too. Now, if you look at it, boom, units cancel. Pretty straightforward. You could also write it. You know that centi is, and let's look actually ahead a little bit. A metric prefixes. You know that centi is equal to 10 to the negative 2. So you could say that, for example, 1 centimeter is 1 times 10 to the negative 2 meters. So that is a perfectly valid fraction too. So you could say, for example, let's say we had 5 meters. And if those are equal, we want to get rid of meters here. So we could put 1 centimeter is equal to 10 to the negative 2 meters. That works as well. And you do that and you still end up getting meters cancels meters, and you still end up getting 500. Because 5 divided by 10 to the negative 2 is really just 5 times 10 to the second. So 2 ways to get the same result. You will see prefixes come up. The most common ones that come up in this class are going to be centi, milli, and kilo by far. You will see, a secondary micro, nano, giga come up. The other ones, well, mega, I don't know. Some of them like deci don't come up, or hecto or tera, they don't come up too much. But you just need to know how to work with the metric prefixes when they do come up, and know that you look on the physics reference table on page 1 and you can find this whole list there. And last but not least for this video, sig figs. The first good news is that we don't worry much about sig figs in this class. If you stick to 3 sig figs, you're usually fine. But as a reminder, all non-zero digits are significant. Captive zeros are significant, meaning zeros between other numbers. Trailing zeros are only significant if they come after a decimal point or if they are followed by a decimal point. And notice those, even though these two here come after the decimal point, they're actually considered leading zeros. Zeros at the beginning are never significant. So you could have, for example, 10 has got 1 significant figure, but you could have the number 10 point, which has 2 sig figs. Or you could have 10.0 or 00, which have 3 or 4 sig figs. And the value is the same if you put them in the calculator, but they mean different things. Generally in this class, as I said, if you stick to 3 sig figs, you're fine. This is not something that you're really graded on, but you do need to know that you should use logical numbers. Don't give me a million sig figs if it doesn't make sense. If you multiply or divide, your answer is the same number of sig figs as the lowest in the product of the divisors. So if 23 has 2 sig figs and 3.703 has 4 sig figs, you should have, whoops, not 4, you should have 2 sig figs in the answer, the lowest of the 2. I would recommend not applying sig figs until you get to the end, though, because you will get rounding errors if you have multiple steps and you start doing sig figs in the middle. Sometimes you can get off. Okay, for addition or subtraction, let's count the numbers after the decimal point. So if your number is like 3.03, that is, the important point is that this is now in the hundredths place. So this is significant to the hundredths place. And you just add or subtract as normal, but then when you're done, you look at the least number of sig figs in terms of in the position, like the tenths versus hundredths. So count the sig figs after each number in the problem, add or subtract normally, and only keep them if they're significant in both. So 23.0 is significant to the tenths. 3.703 is significant to the thousandths. Now, if we add them together, you get what, 26.703, but your answer really should only be significant to the tenths place. So let's ignore the 03. There we go. Going to ignore the 03. It's not ignoring the O. because it's trying to turn on subtitles. Don't know what this is doing. So would we say that should be 26.7 is your answer? Okay. And we can look at some other ones. So let's just do quick. Everything here is significant. The one at the end is significant. It comes after the decimal point, so that's 5 sig figs. This one right here, the leading ones are not significant, so only the 302, that's 3 sig figs. 2100, the 00 is not after the decimal point, and there's nothing after it, so that's really only 2 sig figs. 10 would be 1 sig fig, but 10 point is 2 sig figs. That point adds an extra sig fig. How about this? 3 times 7, we might say is 21, but the answer really should only be 2 sig figs. 1 sig fig, because they both have 1 in them. So your answer would be 20. 11 times 2 would be 22. But these both have 2 sig figs, so our answer should have 2 sig figs, so 22. You don't usually put a decimal point after, you don't usually do like 22 point. You could if you want to, but you don't need it because it already says sig figs. The number 20, you would put a dot after if it was significant to 2 figs, but this one is not. This one's only significant to 1. 60 divided by 6.000, 60 divided by 6.00 is 10, and it is only significant to 1 sig fig because this only has 1 sig fig there. And 100 times 3.005 is going to be 300.5. But we only have 3 sig figs that we can use, so we're going to do it to say 301. I'm going to round. Adding together, 2.0 plus 5.1 should add up to 7.1. And they both are to the 10th place. That's perfectly good. 2 times 5.1 is 7.1 again, but there's only significant to the 1's place, so we're going to just round that to 7. 6.55 minus 4.10 is 2.45. And that is significant to the 100th place. 2.0 minus 0.08 is going to be 1.92, but it's only significant to the 10th place, so that's going to really just be 1.9. So there's some practice there. Okay, that's been plenty long for this video. That's it for now. Thank you very much for watching. Bye-bye.